What is the area of the average triangle? It's a simple question. It's such a simple question. What is it? It's an area. You've put 3 points in an area, you're going to get a triangle. Do it a lot of times, you're going to get an average. If you just call the area 1 by 1, what's the average triangle? Surely that's a known thing though, right? ChatGPT, how many times have you got this question completely wrong whilst maintaining that you have the correct answer? Okay, so we all know ChatGPT, it's BS. What about Wolfram? That's the site for mathematics. When people are not raking leaves in front of your house, it's the best site for mathematics. What does Wolfram have to say? Square triangle picking is the selection of triples of points corresponding to endpoints of a triangle randomly placed in a square. That's what this question is all about. The solution was first given by Wolfram, since attempting to do the integrals by brute force results in intractable integrals. The best approach using computer algebra is to divide the 6-dimensional region of integration into subregions using cylindrical algebraic decomposition. I just realized while editing, Wolfram Alpha does have the solution on there, but they don't explain it. They just say cylindrical decomposition. This is not acceptable. We need an explanation, like where did they get that from? You don't need a computer. Just, I didn't say that earlier. For me, no. There's one simple trick. But maybe someone else on the internet's already done this, right? I'm just some guy with no followers. Surely these guys know what they're talking about.
How you put a candle or a cut on a two-dimensional thing. Before I had many panics about this, I thought I'll just run a simulation rather than trying to solve it on a two-dimensional cake. So you choose a random midpoint for the chord, and you see it hardly ever cuts, or just less often cuts near the middle. And that's a good reason why we're getting different probabilities.
So this part, they weren't actually talking about the 3 points making a triangle, but this is the video that made me wonder about this question, because they never do it mathematically. They just... they should have put 2 candles on a waffle, really.
Or I've got a sphere, and I want you to choose a random point somewhere on the surface of that sphere. I do this all the time in videos that I make. I start a puzzle, I say choose 4 random points on the surface of a sphere. What's the probability that yada yada?
Right, he's asking about 4 points in a sphere and a 3-dimensional space inside it. And he has never done the 3 points on a flat square. Start at the beginning, matey. What is the area of an average triangle? It's such a simple question. Okay, so here's a visible demonstration of the 10 randomly picked triangles and the areas in the colors scheme. So that shows you exactly what the idea is of what we have to do. Now, what's going wrong here? Why do all of these people not know what they're talking about? There is one way to do this and find the answer and find the average triangle. And I want to see it. I haven't done this yet, but I want to see the average triangle. What does that guy look like? We made the average square. Can we make an average triangle? Let's find out. If you don't know the answer, simplify the problem. It's very confusing. If you want to, don't try and start at the top, start at the bottom. What is the average point? Let's start with 1 point on one line between 0 and 1. Now your intuition immediately tells you the average point is 0.5. It's in the middle, it's a half. But why? Why does that work? So what you've done mathematically is find n points of a value of x, 0 to 1 being x, and then you've averaged it, you've divided by n. So you've sum to n and divide by n. And then what we do in mathematics, if we want to do this in a general case, we call it sum to infinity. If you do it 10 times, you get a better answer. Do it 100 times, you get a better answer. You do it 1,000,000 times, you get a very accurate answer. And the sum to infinity is, we do it like this. How do I know that? Because these guys worked it all out, so I don't really have to think too much. It's integration, area under the graph to give you the average point, which is what we do with x. It goes to x squared over 2. We put 1 in because we're going from 0 to 1 are the limits. 0 squared over 2 is 0. 1 squared over 2 is a half. That's the answer we expected. That's the answer we got. Integration works to find the expected probability. So that's a known theory, and I'm sure there's lots of videos on the internet. You can see why that works if you don't know what integration is. We're just going to use it in this problem. Okay, so we've got a point at 0.5. What do we do now? We want a triangle. We're going to need a line. We've got 2 points. Okay, we're going to put both the points. They're both going to average at 0.5. So the length of an average line is it doesn't work like that. You've got to make an equation of your line. So we've got 2 points. We'll call them A and B. The length of your line will be the difference between the 2 points. So depending which one's bigger, if A is bigger than B, it will be A minus B. If B is bigger than A, it will be B minus A. Let's just assume that A is smaller than B. That makes sense, right? A is smaller than B. That's the alphabet. So B minus A is the length of our line. So then we can integrate this expression instead. So we have to integrate B minus A, and we have to integrate it first dA and then dB, which means we integrate A first, so we get BA minus A squared over 2, and we put that from 0 to B, because A is always less than B. So we get B squared minus B squared over 2, which we then integrate dB. B cubed over 3 minus B cubed over 6. B cubed over 3 minus B cubed over 6. I'm trying to do world-beating mathematics here, man. Broadcast yourself. I'm working here, dude. So is the answer 1 over 6? No, because we did A minus B, but there's an equal symmetric probability that B would actually be smaller than A. So for all the possible scenarios, you have to double it, double your 1 over 6, and you get 1 over 3. And that is a sensible answer. If you fire 2 points on a straight line, more and more times, 10, 100, 1,000,000 times, the average length of line that you get will be close to 1 over 3, exactly a third. Makes sense, kind of. Yeah, like a third, because there's like 2 points, so you're going to have 3 bits, right? So it's going to be a third. Makes sense. It's making sense. Because the triangle will be so hard, well, we've got to go for a square, right? Well, if you've got 2 points that make a square of the x, the y is completely independent of the x. So you'll just have another 2 points. It could be a completely separate 2 points, and you're going to have the same. You can separate those two integrals. They're not connected to each other. The 2 points of x will not affect the 2 points of y. So it's 1/3 on both of them. So the average, we're not looking for an average square. With average rectangle, we only fire 2 points because that will give us 4 x and y's. So basically, the 4 points will give us a rectangle, and the average area of a rectangle is 1/9. Wow. So we've got a car parking slowly where they can see directly in, a guy raking leaves, and a guy hammering. I wonder what distractions we can come up with next. So the question becomes, why doesn't this work for triangles? If we've got it all done for rectangles, can't we just put 3 points instead of 2 and get it for triangles? But if you just try and do that, you find a confusing situation. How are you going to get the area of this random triangle? Well, put a rectangle around it and subtract those other triangles, but you start working that out, you find that the integral you get is strange, and Wolfram Alpha says it's intractable, but I'm going to leave it there. You can try and tract it yourself. Until next time, well, I'll unveil the solution.